Hi, my name is Kimon KERAMIDAS. I work on global climate change mitigation strategies using modeling. I would like to thank the IAMC Evaluating Committee for this year's Best Poster Award. The poster presents ongoing work I am doing at the University of Grenoble in the French Alps, together with my colleagues Sylvain Lamima and Adrien Bidot. In the context of international climate negotiations, where countries put forth more and more ambitious mitigation targets, we are looking at how the industry sector could shift towards a low emissions pathway. We are looking at both materials demand and production in an integrated way. In this poster, I have focused on the case of steel, but similar work for cement is being conducted in parallel. On the demand side, here on the top right, you can see the distribution of steel demand across uses. It's not clear whether demand saturation is to be expected. In the modeling, individual uses were associated to drivers to project demand. On the production side, here on the left, is the energy consumption per ton for each process that was modeled. Low carbon options include the use of solid biomass as a fuel, carbon capture and storage, the use of hydrogen instead of natural gas in the direct reduction process, and the use of low carbon electricity. The main section of this poster presents some results. How was this done? Steel demand and production were introduced in the energy system model poles. It's a recursive partial equilibrium model with myopic foresight, and it splits the world in 66 countries and regions. Some variables, like energy prices, are taken from the rest of the model. Overall, the different cost components for steel, such as investment, raw material, energy, contribute to a cost per ton of steel produced, per process and per country. This total cost and existing production capacities are used to allocate production across countries and within countries for the planning of future capacities. The central figure presents the decarbonization wedges between a no policy scenario and a scenario with a single carbon price. Around it, you can see comments and figures with different features, such as the feedback of the decarbonization of the rest of the economy on the demand for steel. There's the competitiveness of certain decarbonization options and various sensitivities. This work reveals the urgent need for efforts in ramping up the deployment of carbon capture and storage infrastructure, for example, and in decreasing the cost of hydrogen, especially considering different hydrogen supply pathways. In future work, we will examine issues like material efficiency measures, or how different countries adopt different mitigation strategies, and what are the trade opportunities for low carbon steel.